Welcome to this comprehensive guide on building a robust command-based input system in Unity 3D, designed specifically for beginners. This tutorial will walk you through every step, from initial setup to advanced features, ensuring you gain a solid understanding of how to implement this powerful system in your own projects. A command-based input system offers a structured and flexible way to manage player input, especially beneficial for complex games or those targeting multiple platforms. This architectural pattern helps in organizing your input logic, making it easier to scale and maintain as your game grows in complexity. This approach encapsulates input actions as objects, effectively decoupling input from core game logic, which greatly enhances code maintainability. By separating concerns, you can modify input methods without altering the underlying game mechanics, leading to cleaner and more modular code. It also allows for easy input remapping and supports advanced features like undo and redo functionality, crucial for modern game development. Imagine giving players the freedom to customize their controls or implementing a robust undo system for strategic gameplay. A command-based system makes these features much more manageable. Let's begin by understanding the core concepts that underpin this powerful system. Grasping these fundamental ideas will provide a strong foundation for implementing the system effectively in your Unity projects. The command pattern encapsulates a request as an object, allowing for parameterization of clients with different requests and queuing of operations. This design pattern is a behavioral pattern that turns a request into a standalone object, containing all information about the request, which can then be passed around, stored, or executed at different times. Input actions represent specific player actions, such as move, jump, or fire, which are defined within an input action asset in Unity. These actions are abstract representations of what a player wants to do, independent of the physical input device used. Bindings link specific input devices, like a keyboard, mouse, or gamepad, to these defined input actions. For example, the W key on a keyboard or the left stick on a gamepad could both be bound to a move forward action, providing flexibility for players. Action maps group related input actions together, such as gameplay, UI, or vehicle controls for better organization. This allows you to easily enable or disable entire sets of controls depending on the current context of your game, like switching from gameplay controls to menu navigation controls. Now, let's dive into the practical steps to build your own command-based input system. We'll go through each stage, from setting up the Unity input system package to writing the C# code that brings it all together. First, install the input system package by navigating to Window, Package Manager in Unity, searching for Input System, and installing it. This package is Unity's modern solution for handling input and is essential for our command-based system. You might need to restart Unity after installation to ensure the package is fully integrated. This is a common step for many Unity package installations, allowing the editor to properly load all new assets and functionalities. Next, create an input action asset by right-clicking in the project window, selecting Create Input Actions, and naming it, for example, Player Controls. This asset will store all your defined input actions, bindings, and action maps. Double-click this new asset to open the Input Actions editor, where you'll define your controls. This dedicated editor provides a visual interface for configuring all aspects of your input system. Within the Input Actions editor, define action maps to group related actions, such as gameplay for player movement and UI for menu navigation. This organizational structure helps keep your input logic clean and manageable, especially in larger projects. Now, create individual actions within each action map for specific player inputs, like move, jump, or fire. Each action represents a distinct player intention, which will later be linked to physical input devices. Set the action type based on the input behavior, button for single presses like jumping, or value for continuous input like movement. For value actions, you'll also specify a control type, such as Vector2 for 2D movement or Float for analog triggers. For each action, add bindings to link specific input devices. Click the plus icon and choose the appropriate input, such as a keyboard key or gamepad axis. You can add multiple bindings to a single action, allowing for flexible control schemes. After defining all your actions and bindings, check the Generate C# class option in the Input Actions editor and click Apply. This step is crucial for integrating your input definitions directly into your C# scripts. This crucial step creates a C# script that allows you to easily access and reference your input actions directly in your code. The generated class provides strongly typed access to your action maps and actions, reducing errors and improving code readability. Now, let's move into Visual Studio to define our command interface. This is where we'll start implementing the core of the command pattern, creating the blueprint for all our input commands. Create a C# interface, for example, iCommand, with an execute method. This interface will be implemented by all concrete command classes. For robust systems, it's also highly recommended to include an undo method in this interface to support undoable operations. Next, implement concrete command classes for each action that will implement the iCommand interface. Each concrete command will encapsulate a specific action and the necessary data to perform it, such as a move forward command or a jump command. For instance, a move forward command would take a rigid body, speed, and direction, then update the rigid body's position in its execute method. This command would contain all the logic required to move a character, making it a self-contained unit of action. The undo method in our iCommand interface is crucial for reversing operations, storing the previous position to revert to. This allows for features like rewinding time or correcting player mistakes, adding a layer of sophistication to your game's mechanics. Now, create an input handler C# script in Unity to manage input and execute these commands. This script will act as the central point for receiving input events and translating them into command executions. Open this script in Visual Studio. First, get a reference to your generated input action class, _player input actions, in the awake method. This ensures that your input actions are properly initialized when the game starts. Enable the relevant action map in onEnable and disable it in onDisable to manage input lifecycle efficiently. This practice ensures that input is only processed when your game object is active and enabled, preventing unintended inputs. Within Fixed Update, read input values, such as vector2 move input, from your _player input actions. Fixed Update is ideal for physics-related movements, ensuring consistent behavior regardless of frame rate. If there's movement input, instantiate and execute the appropriate command, like move forward command, and push it onto a command history stack. This allows you to keep a record of all executed commands, which is essential for implementing undo functionality. For button actions like jump, subscribe to the performed event of the action, as shown with jump.performed plus equals jump_performed. This event-driven approach ensures that your jump command is executed precisely when the button is pressed, providing responsive controls. Implementing undo functionality is optional but highly recommended for robust systems. It adds a layer of flexibility and user-friendliness that can significantly improve the player experience, especially in games where mistakes can be costly. Create a command invoker class to store a history of executed commands, typically using a stack iCommand. This stack will keep track of the order in which commands were executed, making it easy to reverse them one by one. Implement an undo last command method that pops the last command from the stack and calls its undo method. This method provides the core logic for reversing actions, allowing players to correct errors or experiment with different strategies. Here are some helpful tips to further enhance your command-based input system. These best practices will help you optimize performance, improve maintainability, and create a more polished user experience. Use Unity events for simple actions that don't require complex logic, providing a quick way to trigger functions. For example, a button press in a menu could directly trigger a load scene function without needing a full command object. Consider using a singleton pattern for your input manager to provide global access to input handling throughout your game. This ensures that there's only one instance of your input manager, making it easy for any part of your game to access input data. Utilize the Input Debugger in Unity to monitor input events and troubleshoot any issues you encounter. This powerful tool allows you to see exactly what input devices are connected and what events they are generating, which is invaluable for debugging. Disable unused actions and action maps for better performance, ensuring only necessary input processing occurs. By only enabling the input maps relevant to the current game state, you can reduce overhead and improve efficiency. Implement different control schemes for various platforms or player preferences, offering a customizable experience. A command-based system makes it straightforward to swap out entire sets of bindings, catering to a wider audience and improving accessibility. By following these steps, you can create a robust and flexible command-based input system in Unity, laying a strong foundation for your games. This system will not only make your input handling more organized, but also open doors to advanced features and better player experiences. Thank you for watching this tutorial. We hope this guide helps you build amazing interactive experiences in Unity 3D. Don't forget to like, share, and subscribe for more valuable content on game development.